the Python approach. And so for that, I saved a few minutes, hopefully, by already downloading Slicer 4.4. And so most of you probably already have this installed. I just wanted to show you that it really is this easy. So, well, not a problem. That's okay, it goes a bit quicker. So what I'm going to do now is basically use a module that comes built with Slicer. Either you build it yourself as per the instructions, or it comes in the pre-built download that's called the Extension Wizard. And its job is to create extensions and modules for you. So previously you could either create or copy an existing extension, an existing module, go through and edit all the files, and that's essentially what the wizard does under the hood, but it makes it really quick. So there you go. What was that, a minute maybe? Oh, let's make sure I get the right one. There we go. So many of you are probably pretty familiar with this interface, but you just go up here, you can see my cursor up at the, and you just start typing. So this is what you're presented with, and a very short description of extension versus module. An extension is a collection of modules, and a module is the code and UI and resources that actually do stuff. So for example, Slicer RT is an extension. Yeah, let's do, why not? 2 seconds. So Slicer RT is an extension, and it contains 15, 16, 17 modules, each one doing a different step on the chain. So most of you are probably pretty familiar with this. I just wanted to show you or explain to you the difference, so that when we go back to the extension wizard, the first step is to create an extension, and you give it a name. What? I don't know. Let's be professional. For now, I'm going to skip the explanation of a default versus a super build. A super build is when you start getting into some pretty major, like Slicer RT is a super build. It downloads external projects, it downloads Plastimatch, and builds all those libraries. So if you're building a pretty advanced extension that depends on a lot of external libraries, I can do that in a much more advanced tutorial. But for now, we're just going to leave it as default, which is sort of your basic. Here, your directory should be your root. So another small digression is your build directory. You'll notice that my scripts don't look like quite the ones you may download. That's because I created these a long time ago, and then the Queens group made similar ones that are better, and I just never switched. So this is me being lazy. If it's not broke, don't fix it. So to have a central build directory, you're probably all used to that, I hope. The only downside, and the reason I bring this up, is that Slicer has path name length problems. So if your root development directory is already C, users, Rankin, documents, projects, Slicer, you're going to run into build problems because it tries to append a lot more to that, and you end up breaking Windows. So my development root directory is d:/d for a reason. It drives me nuts, but such is life. So the reason I say that is because here you need to choose your root directory, and so that's why I'm choosing my development environment here. You hit choose, and you hit OK, and here you go. So categories, there are, of course you would, but there are a number of pre-created categories that you're probably all pretty familiar with. Wizards, informatics, radiotherapy, segmentation, all these things. So you could either put it in one put it in whatever applies. So this is going to be examples is pretty good. So, and here, yes, great. So basically this is sort of the metadata, and this is what the extension is the metadata, the packaging of the module, so that's what this applies here. And here you go. You have now created your own extension. That's it. So it used to be like this CMake file starts out pretty simple. Don't worry about it. I'm just showing you that it's short. Don't worry about all the details. This is how it starts. And in the end, it can become a 600, 700 line monstrosity with lots of advanced commands, but it starts out really simple. You get your metadata information, and you'll notice that this is empty here, because when we go back to Slicer, and we say add module to extension, you give it a name. And so what are we going to do in this module? Let's say, I don't even delete data. And here's where this would be, so later on in the tutorial, this is loadable, creates a C++ module, CLI creates a command line module, and scripted creates the Python module. So I'm going to create a Python module because that's what I want to show you right now. And great. So because this is a Python module and Python is interpreted, it can actually load this right now. So that's what we're going to do. Yes. So really, under examples, we now have a new module. This runs. This is it. So that's right now. So it's the extension wizard takes a blank a semi-blank template for loadable, scripted, and CLI, and creates a copy of that for you to edit. So what I want to show you now is how quickly you can edit the module. Hang on, there's a way to get into developer mode. Hang on. Sorry, guys. Huh. Okay. Well, that's embarrassing. I actually don't know how, but not a problem. The wizard created an extension or a module in your extension called delete data, and it contains some resources, which is basically the icon for your module, a testing folder that you can later write scripted tests, a CMake list, and most importantly, a Python file. So in here is where you get to your scripting, and this is where I said if you want to do this, you will have to learn a bit of Python, but don't worry, I can come and help you out and point you to the really important part, which is basically down here. So you are defining your interface via Python script. And so it gets a little bit fancy, but what I want to show you, select volume. I would just personally do, there it is. And if I had found the right button, you can reload it live, but this is almost as quick. E is for examples, Adam. Did I break it? Ha! Isn't that something? Well, there you go. Did not do that yesterday. Wow. Sorry about that. I have no idea. Well, that's embarrassing. But I will look into that afterwards and get back to you. Yes?
If you have a module created, is there any way, like let's say you made it on one computer and you want to install it on another computer?
Yeah,
is there
so...
any way to load a module that's already created?
Yes. For Python, it's of course pretty easy. You can just copy that entire folder, and then under application settings, modules, locations, you can add stuff to it. That would be the quickest way. For built modules, of course, you have to be careful that you've built on the same OS, same bit. That's when it gets complicated. If you're talking about actually like releasing your module to the wild, I would do the extra effort to get it into the extension manager, because that is also really convenient for everyone else. Yeah, go for it.
So let's say you're working with DDK that has both C++ binding and Python binding. you recommend going with the Python module or C++?
Python, for
And-
sure.
But, okay, then this other library that doesn't have Python binding, you have no choice but to work with C++.
Yes, that's right. So there's a module in an extension, the gel dosimetry extension. That is a Python-based like individual modules are all Python, but it's a Python-based extension that compiles C++ and runs it. So the nice part about Python is that it's really lightweight to link load your data. Everything's really fast, and if you make a mistake in your code, you don't have to spend 45 seconds, which you think, 45 seconds, no big deal, but do 45 seconds 18 times an hour, and all of a sudden you're wasting a lot of time. Whereas Python, you can literally just get through all the coding bugs quickly so that you're actually spending time on your algorithm. So I admit that I've never done a Python module with C++ library under the hood. That's something that I'll be checking out in the next few weeks, because I've been basically solely C++, and I think that the Python-based modules have a lot of potential.
Do you know if there's a study about the penalty in terms of performance using interpreted language?
Well, so no, I don't have any stats or any numbers, but I mean, obviously Python being interpreted will be slower, except that if you're doing all your Python work for all the boring stuff like loading data and setting things up and calling other modules, and then your algorithm is VTK compiled in C++, then honestly your performance hit is going to be so negligible that the time you save coding up all the setup stuff would be saved in overall. That would be my opinion. So
how does the command line interface module work?
Again, another set of modules that I don't have a lot of experience with, but it's a compiled module without the sort of infrastructure of the loadable module. So it will...
Any arbitrary command line programmer, does it have to be a slicer module itself? Could you wrap any sort of binary?
I think so. Again, I'm sorry, I have never really worked a lot with it, but I think so.
Okay.
The one I have experience using, not creating, is Model Maker, and I'm pretty sure that's just, it creates, you define a text file, and it creates a GUI based on that text file. So you say, I need a double input, and so now you can type 2.8, and I need a Murmo volume, 3D model to go in. Okay, so now give me a volume selector. Okay, and so it would build a really, well, I'm on camera, so I won't say that, but a very rudimentary UI, which works. And one might say it's attractive depending on how much you like Slicer UIs, but and then it just passes those parameters to the Model Maker, and there's a really nice interface between shipping data out of Slicer and bringing it back in that is pretty well established. So
does that exist from the Windows command line or command line within the Slicer GUI?
the GUI, basically Slicer calls the command line code, like the executable.
Yeah.
So you would actually see a command line module shows up in your list.
Okay.
In fact, is Model Maker still here? I always go to, yeah. So there you go. So this GUI is a text file that Slicer auto-generates a GUI for. And when you're done and hit apply, it takes all these parameters, formats them into a command line string, and runs it.
Okay.
So if you have other projects that you've done lots of work and you don't want to reinvent the wheel, both Python calling C++ libraries and CLI calling already built programs is a pretty nice way of doing it. The executable needs to be Slicer aware, as in it needs to read and write the way Slicer knows how. But for most established programs, that wouldn't be, I don't think it's too intense. And you could just say like -- slicer, add that to your program so that it knows to output a certain way. I don't actually know the underlying technique for loading data. I wonder if it writes it out to file and then Slicer reads it in a known format. I think that's how it works, but there's some sort of communication mechanism. So this is driving me nuts. Where did examples go?
Can you talk about 64 bits versus 32 bits?
Sure. What would you like to hear?
Well, they say, if I want to interface certain drivers.
Yeah, okay. I figure that's where you're going. I mean, essentially, I would do 32-bit only if you have to. So I'm guessing that there are points where you have to. I guess,
But they say if you want to write something that's meant to distribute it to other institutions, I assume you compile these modules, right?
yes, yeah, so,
So you want to compile it in 32-bit just so that everybody can use it?
well, so if you're distributing it to other institutions, use the extension manager.
Yes.
The extension manager detects the build type, detects the platform type, detects everything,
Okay.
and downloads the right thing. Like, the extension manager is awesome. It's super complicated, and the tutorial for that is another 2-hour masterpiece, really, but it's worth it because you have to do a little bit of infrastructure work at the beginning, which is, again, how I say I like to roll, and then all of a sudden, anyone, anywhere can download your extension. So it's not so bad, especially if you have someone who knows how to do it helping you. So, if you actually want to have people use your code, come bug me and I'll show you how to set up Midas, which is your data repository, and set up your account, and it's worth it, for sure. As you saw, like, I downloaded Slicer RT in a few seconds, and now all of a sudden there's lots of, boy, this is a nice module. I wonder who wrote it. I didn't, I helped. Yeah.
How does threading work when you make a module? Like, let's say, you have one thread that's pulling data from a tracker, and another thread that's processing things, or...
Well, so if you're pulling from a tracker, in that case, you're going to have lots of different executables. Like, you're going to have, well, it depends what you use. So, for example, Plus could receive track data, image data, and that would run in its own executable, and it's multi-threaded, so it would have threads. And then you'd also have Slicer running via an OpenIGT link bridge, and that has its executable with its number of threads. So it's, it says,
Plus intentionally separated because there wasn't the flexibility to have that built into Slicer? Like, does it just make things more complicated to try to have Slicer spawn off its own thread instead of a separate process?
for it to have its own thread, you'd need to have Plus implemented in Slicer or load the DLLs, or, I guess you could, but it's just so much cleaner to keep a separate specialization and then just have a bridge, in my opinion, I guess. But yeah, Slicer, multi-threaded is up to you in your code. If you want to do everything in your single-threaded module, you can. But
Would it block the UI then?
nope. So sorry, I guess that's, yeah, no. Slicer UI is separate from processing. Slicer still locks up because you can't do anything else. But where's a good example? MATLAB bridge would be cool. I have no idea where that would be. Why do I always go to the list? No. I think you have to install it.
What are the restrictions on 3D Slicer running in 32-bit versus 64-bit?
I think really memory space is the big thing. Slicer, as we all know, is pretty intensive. So if you can only address 4 gigs in theory,
Seeing
that-
crash loading CD images, for example.
yeah. So 64-bit gives you more memory than is currently manufactured. So, although I just read a study of a SanDisk, I think, created a 300 gig SSD that can plug into a memory slot. So it performs like an SSD, which we all think is great, but compare that to memory, there's no chance. But in theory, if you're running a virtual server farm and you need 1.2 terabytes of memory, you could do it, which is kind of neat. Slower, but if you're serving web pages, maybe it's good enough. Sorry, get all excited. Okay, so I'm really sorry that I will look into why examples no longer shows up with no error. But let's pretend that it did work and it did show up, and there's a module that now says a slightly different string. And if you like, or if there is demand, I can do a Python tutorial after I learn it, and that might be of value for people who just want quick and easy. Yeah.
Maybe it would be worthwhile revisiting this, but sort of including a demonstration of how to set up a relatively simple image processing task, starting with blank slate, including loading, processing, and exporting the data.
So my tutorial section ends on a what do you guys want to do? So I highly suspect that there will not be, well, there could be enough time today if none of you had anything else to do, but everyone has anything else to do. So maybe we could set up a non-lab meeting based thing. Yes.
So question from ignorance. Are the modules designed to be more standalone, or is there a possibility for a lot of inter-module communication? I'm coming from this as someone who likes designing individual pieces and stringing them together.
Oh, that's the definition of slicer. So each module is supposed to be independent. In fact, that's a pretty hard requirement. If you commit to the slicer core, yeah, there's a very insular boundary between every module. And the idea that each module performs its specialized task. And what that's done is that nowadays you can use Slicer for different things simply because loading data is its own module, and then segmenting data is its own module, and then this is like, it's all a chain of events that operate on standardized data formats in memory. So yes, your modules should be independent. So the contours module, for example, in radiotherapy, its job is to manage contours. But then the contour morphology, its job is to play with contours. So they both operate on the contour data type, but they're completely independent.
I'm just wondering if you have, say, 2 data sets,
Mhm.
and you do something in order to get contours for them. So now you need sort of 2 instances of some sort of contour creation module, and then you want to perform some sort of morphology operators on that. You may need 2 instances of another module. Is there any support for, I'm thinking more complicated pipelines than just you have 1 instance of each feeding into the next and that's it. I'm thinking from my perspective, coming from like my general purpose segmentation stuff, I may want to have a large number of input or modules inputting into a sort of segmentation solver. So having, n different data term modules and n different smoothness term modules, all leading into a single, solution module.
So-
How possible is that?
I think you would take a slightly different approach. Now, I admit I don't fully understand exactly what you're going with, but I think I could provide a little bit of insight. What you would have is a data type. So I won't get too technical, but those are MRML nodes, and those MRML nodes have data and accessors. And then your modules are sort of the action on the data type. So you would write, if you have a new segmentation method, you would write a new module for segmenting, I don't know, if you use model data, you could use the model node. If you use image data, like 3D image data, you can use the image data, MRML scalar volume, stuff like that. So you would have a segmentation module operating on many volume nodes or image nodes or whatever you want. And if you want to pre-process those, you would have another module that would pre-process. So its input would be a data node, pre-processed data nodes, pre-processed data nodes. Data nodes segmentation label map, whatever your output may be or something. So it's not that you have many modules each performing on its own data set at a time. It's you have one module that performs an operation on a data set. So what you're getting at is, I think if you want to start performing multi-step tasks within a single job, that's when you start creating modules whose job it is to run other modules.
Oh, so there is a way of having that sort of
You can,
quote-unquote super module.
yeah, that's right. And so I won't get too far into the philosophy of Slicer, but that's sort of a more recent development. The idea being that you would just create a Python module and script it right out. If all the hard work is done in other modules that are very efficient and optimized and great, then you might as well just create a super lightweight Python module, or command or loadable if you're more comfortable or if you want more control. But just create a Python module and just start, load data 1 through 37, call segment on all 37, then call morph on all 37, and then so yes, you're right. There are modules that string together other modules. So that would be, yeah.
I guess, I mean, it's also just important to know that Slicer wasn't developed with that purpose in mind. The idea of,
You-
pipelining, batch processing large data sets and things like that. I mean, I think they're starting to.
I mean,
develop
in the end, you could. Like, the thing is, the definition of what Slicer does is very, very small, and that's what allows such huge flexibility. You just create modules, and they do whatever you want. If you stick to their sort of philosophy and create single job modules, that's great, because then someone at a research lab could come along and string together 37 different modules that each do their own little puzzle piece in a very quick and light Python module, and all of a sudden this research data gets through fast because all these little pieces are very optimized and fast, and you just do all the data loading and handling and passing around in Python. So that's what I haven't done recently. Just to go back to your early comment about which would you choose, I think in the future I would spend time learning the Python approach so that I could try, like, let's see how short of time it takes me to write a module that calls 12 different modules that does a neat job. So that would be something that we could do another talk on as well.
I
So
think that would be a valuable
Yeah.
sort of skill, because that's one thing I could imagine most of us
you want.
doing. Like,
Yeah.
we have some sort of image-guided therapy in mind.
Yes.
We know, we have a flow chart for how
Yes.
we want to solve
Yeah.
it.
So Slicer
The way
IG.
that-
Sorry to interrupt. Slicer IGT has some extensions that are meant to string together workflows, and so that's a. Sorry, I'll just download it while I. Yes, so that's a more recent approach, is to have these sort of workflow-based modules instead of single job modules. So.
How the documentation on the build modules and the hooks and those things you actually still together?
Yes, so strong, depending on the author. This is all open source, but
Is there a central repository where we there?
yes, in fact, why not? Now's a good time. There has been a lot of work into this developer wiki. With my potato internet connection. So on the left, you see developer's manual. Okay. Weird. So I think this is an example of, this is an example of a module that uses other modules. I think this requires the an Active Plus connection, which is another module, and so it does multiple things. So okay, so to answer your question, each module, if you do it through the extension manager, auto-generates a wiki page on here that you are to go and fill out as part of being a good Slicer developer. So why don't I just find one that I already know about. So here is what I was browsing a few days ago, because when I pulled this together I thought it was going to be what I was used to, but it turns out they changed it to this nice GUI approach, which I'm a big fan of. But in fact, here's an example. This wiki page still describes the command line approach to creating an extension wizard. And so I spent a lot of time, installing a bash shell and trying it out and getting errors. And then I talked to one of my colleagues at Queens, and he's like, "Why are you doing it that way? Why don't you just use the GUI? It's much nicer." And I went, "Wow." So not perfect, but overall pretty strong. So here's the documentation, for example, for Slicer IGT, and it's not too populated because it's sort of niche. But if you go to some of the core things, like where's the brains? So in the brains, so this is, what's that, registration algorithm. There is lots of documentation about how to call it. And I think, so the brains module is actually just a CLI module. So these are all the different parameters that you can pass to the external command. And so this is describing what all the different parameters do to the external command. So it's author dependent, but I would say my opinion is, for the most part, most authors do a pretty good job of providing information. So, okay,
Okay.
Thanks.
no problem. So I think if people want more, or want even more technical, like how to actually like create the module, edit the UI, stuff like that, obviously come see me. But if I get lots of people coming to see me, then maybe I'll throw together sort of an informal or semi-formal talk. So, thank you.
I haven't looked at the site, the last wiki, so maybe it's on there anyway. Is there like a walkthrough tutorial that you just kind of?
Well, walkthrough for what? I've given you a walkthrough for setting up your build environment.
Like example slicer module to build. Let's say click there.
Yeah. So the only thing I haven't added, well, so this page right here, all of this from what to install to what to click, stopping it here, this is sort of, I didn't know what people needed, so this is where we go next, but all the way up to here, this is creating a new module for you to go and play around in. So this is C++, but Python is, instead of choosing loadable, just choose scripted and start editing away. And if the category you're editing in disappears, we'll go figure out what that means. So, yeah.
So one quick question. So
Yeah.
is there a quality control? Let's say you write a module who says...
No, it's up to you.
So anybody can publish anything?
In the extension manager, absolutely. In the Slicer core, the quality control is extremely strict and worth it. But no, this is the App Store. The extension manager is an App Store. So you can download an app on your iPhone that'll steal all your personal data. Or you could download one that does all your banking, right? It's a free market enterprise. So, okay. Well, let's wrap it up. Thank you very much for listening, and have a good day.